So I'm making this video to help you determine how to calculate what the heat capacity is of a calorimeter in a calorimetry problem. And the scenario is that heat is being applied to a system, and let's say the system is the calorimeter right here. And the calorimeter contains two parts. One part that holds water, specifically in this example 200.0 grams of water, and then there's the calorimeter itself. So I represented that by this wall outside that's holding the water. So one of the questions is to determine how much heat the water absorbs, and the classic heat equation is this one right here. So the amount of heat absorbed by the water is going to be the mass of the water times the specific heat of water, or the heat capacity of water, times the change in temperature. But an ultimate goal of this problem is to determine the heat capacity of the calorimeter. So knowing that both of these systems, or both of these items, both the water and the calorimeter, are going to be absorbing some of this total, in order for us to calculate the heat capacity of the calorimeter, we have to get what we can easily find information about. And the problem gives us that the mass of the water is 200 grams. It gives us what the heat capacity is of water, which is 4.184 joules per gram per degree Celsius, and the temperature change of 1.10 degrees Celsius. So plugging these numbers into this heat equation, we get 200 grams times the 4.184 times the 1.1 degrees Celsius. And that tells us that about 920.5 joules of heat was absorbed by the water. Now, if 1020 joules was applied and 920 of that was absorbed by the water, the remainder of it was absorbed by the calorimeter. So the second step is to figure out how much the calorimeter absorbed. So if we take our total amount that was applied to this system, and which we know is 1220, and subtract the heat that the water absorbed, we find out that the amount of heat the calorimeter absorbed is 99.5 joules. So relatively small compared to over 900 absorbed by the water. So this equation is just kind of written out, showing that the heat absorbed by the calorimeter is the total heat minus the heat absorbed by the water, which gives you 99.5 joules. So there's an equation in calorimetry to find the heat capacity of a calorimeter. And the equation is that the heat of the calorimeter is equivalent to the heat capacity times the change in temperature. And I've rearranged that equation so that we're solving for the the heat capacity of the calorimeter. And to solve that, we need the heat from the calorimeter divided by the change in temperature. So the heat from the calorimeter is 99.5 joules, which we calculated right up here, and the change in temperature was 1.1 degrees Celsius. So the heat capacity of the calorimeter is going to be 90.5 joules per degree Celsius. So I hope that helps you get through how to navigate the problem. Calorimetry in general kind of hard to understand. It's all about heat flow and heat coming from a source, and that heat being absorbed by other things. So I hope that this helps.